Hello, and welcome to the Demonstrating Implementation Excellence stream of the SNOMED CT Expo 2020. I'm Susie Roy. I'm the Customer Support Lead for the Americas at SNOMED International, and I will be moderating this session. Please use the Q&A box to type in your questions to the presenter. All questions will be answered at the conclusion of the presentation. I am now very pleased to introduce Marcelo Daniel Carrascal Pascual. He is the CIO and Project Manager at Project Andes, and he has an appointment at the Provincial Hospital in Neuquén, Argentina. And today he's going to be presenting development of a BI tool based on SNOMED CT and the SNOMED CT Browser. Marcelo, please begin.
Well, hello to everyone, and thank you for this opportunity. My team and I work in a high complexity hospital in the province of Neuquén. Neuquén, as you can see in the map, is located in the north of Patagonia, Argentina. And as you can see, this project was conceived almost at the end of the work. So we are honored to be presenting our work in this event. And we want to thank SNOMED for giving us the opportunity to be here today. So, after having worked for almost 22 years in the healthcare system, we faced many problems when implementing IT solutions. Solutions for one domain were a problem for another domain in general. One day, we discovered SNOMED, we studied SNOMED, and we understood SNOMED. And one of the most important things SNOMED says about SNOMED is that it is not a binary solution. It is not all or nothing. We fell in love with SNOMED because it helped us solve what seemed to be unsolvable issues we had been dealing with for many years. Therefore, we decided that SNOMED was what we needed. So, what we have? For many years, all healthcare facilities in the province had an electronic information system implemented, but there were still many problems. In 2016, after the Unified Digital Health History Act passed, we started working on the fourth version of our electronic health information system. But this time, there was a big difference. We had SNOMED. The electronic system we implemented is based entirely on SNOMED. Each piece of information in this system is associated with a SNOMED concept: diagnosis, procedures, observable entities, titles, labels, findings, products, everything. In fact, we should say that almost 99% of our master tables have been replaced by some tool offered by SNOMED: value set, ref set, expression constraints, etc. SNOMED is the cornerstone for our project, called Andes. What were the results? We work with agile methodologies, and after 4 years of 2-week sprint and after writing hundreds of thousands of lines of code, our database had a reservoir of approximately 15 million SNOMED concepts. So, what do we do with that information? With such amount of information, the answer was obvious. Where is the database? To answer what questions? The traditional questions: how many patients were treated, what are the main diagnoses, the main pathologies grouped by sex, age, the tracer indicators of health service coverage. And of course, these answers are crucial for the proper functioning of a health system, but we already had the answers to these questions without SNOMED. So, what were the benefits of having invested such amount of time and effort to implement a tool using SNOMED CT? In theory, we all knew all the benefits. SNOMED is a semantic standard. It represents clinical ideas clearly and unambiguously. It is a qualitative leap in the implementation of electronic health information systems, improves medical records, helps to reduce errors in the healthcare process. So, it was time to prove it. So SNOMED became a non-traditional way to record information for us. So what we expected was to be able to obtain non-traditional information and results. We've got, at the time, our reality was that we had 15 million concepts, SNOMED concepts stored in our database. Not just isolated concepts, but we had strongly related concepts through an underlying ontology. We already said that we needed a tool to answer the traditional question. For obvious reasons, it was not possible to leave aside statistics and traditional epidemiology, but it was also necessary to explore the oceans of data we had, and we had to reveal what lied below the surface. We tried to build different tools, but those that were good for answering some questions were useless for answering others. The main problem was were how to explore and how to visualize such amount of information. So we found a solution. We already had an exploratory tool for SNOMED, the SNOMED CT Browser, a well-known tool and very powerful. So the browser allows us to explore and understand existing concepts and the relationships between them. So what does the browser explore? SNOMED concepts. What do we have in our databases? SNOMED concepts. So the solution was to redesign and adapt the browser to explore the concepts stored in our databases to answer our own questions. So within the image, what appears to be the SNOMED CT Browser. However, there are many differences. What we did was to preserve the basic exploratory functionalities that make the browser so powerful. We can look up for concepts, here you can see. We can apply filters, like, for example, by hierarchy. We can visualize the characteristic of the concept here at the bottom. And we can see the relationships of concept with its ancestors, its descendants, and its attributes. We kept a familiar aspect to ensure that those who already knew how to use this tool would continue to feel that familiarity. However, the tool displays information about what is stored in our databases, information important for us. It shows some traditional information, but it also shows new information that can be obtained by exploring the data through the relationships that exist between them through SNOMED. So what we can see is that we've searched diabetes mellitus, and we can see is that we've got 32,799 records containing at least one concept of diabetes mellitus or its ancestors, that we've got 7,600 approximately concepts containing exactly the concept diabetes mellitus, and we've got 25,093,000 records containing at least one descendant of diabetes mellitus. So the browser is showing non-traditional information for us, which is important for us to know what happens in our database. The browser, our browser also has different tabs. We can see the Details tab, the Patients tab, the Locations tab, Facilities, Professionals, etc. Let's take a look at the Patients tab, for example. After searching for a concept, diabetes mellitus, when we select the Patient tab, we will see information organized in a traditional way, but we will also see non-traditional information depending on the hierarchy to which a concept belongs. In this case, we are looking at information on diabetes mellitus, a diagnosis, finding, a disease. We can see a table showing the number of records containing the concept diabetes mellitus or any of its descendants organized by age and sex. We can see too that there is a menu there that allows us to select the type of metric we want to visualize about the concept we've selected. As it is a concept belonging to the diagnostics hierarchy, we can also choose to see the number of patients who have any type of diabetes mellitus in their list of findings. This does not seem too innovative. But what happens if we search for an observable entity concept? If we choose a concept belonging to the hierarchy of observable entities, such as body weight, we would see that a new metric would appear on the menu. This metric allows us to visualize central tendency measures calculated from the values that the concept or any of its descendants have taken in the electronic record. We can see the number of times the value of the body weight or any of its descendants has been recorded, the number of patients for whom the body weight value has been recorded, and we can also see values of the median, the first quartile, the third quartile, the upper fence, the lower fence, and the maximum and minimum values recorded for body weight or any of its descendants. In this way, it is possible for us to calculate population values virtually without any additional effort. This way of visualizing information has some secondary benefits. As you can see in the median, the value of the median of body weight for women about 50 years or older, we will see what seems a possible error. The median weight should not be 129 kilograms. So, this result was obtained from making calculations from all the values taken by the concept of body weight or any of its descendants. So, we can recalculate the values, including or excluding any of the concepts involved. As you can see, this number was calculated from all these concepts. So we can select which concept to use to recalculate, and by identifying which concept contains the wrong value, as we know to which SNOMED concept it belongs, and we can find any of that concept in any record in our databases, it is possible for us to alert professionals to correct possibly erroneous concepts. Let's see what happens with the Associated Concepts tab. After selecting a concept, it is possible to obtain the most frequent associated concepts to it related through the list of patient findings. For example, we search for the concept schizophrenia, and the algorithm performs a search of all the patients that have some type of schizophrenia in their findings list, and displays the most frequent concepts that are also found in those lists. It is possible to show the most frequent pathologies, the most frequent findings, the most frequent procedures, products, etc. The results can be seen in a table or graphic. Yes? It is not surprising to find some natural associations of schizophrenia, such as psychotic disorder or substance abuse. However, unexpected relationships also appear, such as ankle fractures in the 18th place. Based on this finding, it could be determined that those patients who share some type of schizophrenia and ankle fractures in their list of findings have in common in their medication list drugs that cause coordination problems among their effects. And as we said, we can apply these tool to any concept, one good example is to see what happens, for example, with the social determinants of health, because we can analyze associations with any concept. It was particularly interesting to study the relationships generated by the social determinants of health. For example, lack of work brings associated concepts from the list of diseases: alcohol dependence, substance abuse, psychosis, etc. If we look at the findings, we will see low income, parenting-related problems, problematic behavior in children, life crisis, history of domestic abuse. That is a snapshot of reality without the need for long and expensive studies. The social and health reality seen only through electronic records. Let's take a look at the map tab. We can also search for any concept within our database and make an analysis through the map tab. For example, an outpatient pediatric consultation. The first thing we look at when defining an outpatient pediatric consultation is that it is no longer a consultation made by a pediatrician, but rather all consultations made to a minor. Through SNOMED, we can redefine some useful concepts. As all our patients are georeferenced, it is possible for us to see the information of any concept related to a patient on the map. In the first figure, we see a heat map of all the consultations made to pediatric patients. We see that there is good accessibility within the province. In the second map, we see the locations of the healthcare facilities that offer that consultation. There is a very good distribution of professionals through the province. But what happens if we look at the pediatric neurology consultation? The first map shows that we have a very good coverage too. However, in the second map, we see that there is only one health facility where these consultations are done. What is the deduction? That this shows not only that we've got good coverage, but also that the reference and counter-reference system for children's neurological pathologies is working very, very well. Of course, we've got maps for everything. For example, breast cancer, where we can see the density of the disease. We can see the facilities where breast cancer is treated, and we can see where the patients live. And this allows us to distribute the work in an efficient and equitable way and to carry out the follow-ups and provide better quality of health. We also introduced a BI tab where we included a multivariate analysis tool, a data cube for those interested to carry out more complex analysis of the information. The last things we've been playing with are the graph tables. We have started to study relationships between concepts through networks, the relationships between procedures, facilities, professionals, pathologists. What relationships are there between them? Which consultations are carried out in different health centers, which patients they are. They will allow us to analyze information and find patterns of behavior of organizations, professionals, and people, and will enable us to optimize the use of resources and achieve a better healthcare system and a better results for people. So those are images of what can be done. So to conclude, the browser became our main tool to explore our database and is the core element or cornerstone that allows us to answer traditional questions, but also to navigate the data to find new relationships and new patterns. It is an example of how useful, scalable, reusable, open source standards-based tools can be evolved into even more powerful tools. It shows the synergy between traditional and new to improve people's health. And let me tell My last word. Both my team and I work in a tertiary hospital with COVID units today. While this session is taking place, there are many people suffering and dying from COVID on the upper floor of this facility, and many people are working to mitigate this pandemic. This work is dedicated to all of them, to those who are working, to those who are fighting for their lives, to those who died. The best way to honor them is to work so that their suffering is not in vain. Thank you very much for giving us this opportunity.
Mucho gracias, Marcelo, para tu presentación and everything. Very, very excellent. Okay, and can I please ask the audience attendees to please just give us a moment while we switch over from our pre-recorded content so that Marcelo can address the questions that you have been submitting live. Please also note that this session will be available on the event platform for the. Okay, thank you. And I see some questions starting to come in now, and we have a little bit of time. So getting right into these. Okay, Harmak Groot says, very interesting presentation, Marcelo. I was wondering, what is done in the case of missing data when representing the descriptive statistics? Is that taken into account in the BI tool? Otherwise, there may be a lot of skewed data, he wonders.
Well, that is an interesting question because there are no missing data in our application because that's another work, the first work we presented in Vancouver Expo. Our application is completely dynamic. People select the information they want to register or they want to record. If so, there is no missing, there's no missing data. That is why we can show if they are interested, they can contact me in the networking area, and I can show an example of how Andes or the application works. That is another interesting feature of the application.
Great. Tim Volkert says, impressive work. Indeed, it is. And Damian Yunere says, oh boy, hola Marcelo, saludos desde Paranas, Ríos, Argentina. Buena presentación, felicidades. Lo siento, mi español es muy malo. Yes, very impressive work, Marcelo. Lots and lots of work. I was wondering, you have done so much work already. What are you excited for next?
I've got some audio problems. Perhaps if you can write it to the write the question down because the speakers are not working properly. I don't know what happened.
Oh.
Yes, I can see you typing you there, Susie.
Sorry about that as we get through some of our technical difficulties. So what are you interested in next?
Well, what is next? We do not know what is next because we work with agile methodologies. So the word is for us, and the tasks are continuously changing. We had some planning, but the pandemic turned our world down. So what is next is to keep working, to keep innovating. So that is the spirit of our work and of our group. So we do not know what's next. Hope something innovative to help people.
Excellent. Are there any more questions from the audience?
Well, if there are no more questions, I will be in the networking section, and everyone can contact me through LinkedIn or my email. I will be pleased to show our work or perhaps a live demo. We are always available for showing our work and sharing it. So thank you for this
It looks like
opportunity.
you did get one more question, Marcelo. They squeezed it in before we wrap things up. How long does it take to implement?
Well, we have an advantage. As I told in the first or one of the first diapos, our province had the advantage of having information systems, and this was the fourth generation of information system. It took about 3 years to implement not these tools. It took about a year, and it is still in development. But what is interesting about this is that it is never concluded. We keep iterating on it to improve it. So it's an infinite cycle, I think. But we've been iterating. We've got 52, no, about 100 iterations of sprints, Scrum sprints, and it's about three years approximately. The whole project, not only the BI tool. BI tool, it took about 1 year.
Very, very impressive. Okay, as Marcelo indicated, he is available. He'll be around the expo, either on the networking lounge, or go ahead and ping him, message him in the application platform, or he's also available on LinkedIn. Seeing no more questions coming in for now, thank you all for attending, and we'll see you in the next session. Thank you.